Good evening. We'll start discussing mathematics for economics, and the topics that we'll be looking at the topics of on matrices, and the topic on differentiation and its application to economic scenario, and then we'll be looking at the topic of calculus and how this calculus again is applied in economics, and then thereafter we'll discuss a topic on optimization, and having discussed a topic on optimization, then this is actually regarded as a comparative static, and then we'll look at differential equations, and then finally we'll look at the difference equation. So these are some of the important topics that we'll be able to discuss in this class. So we should be able to go through and understand properly. So let's look at the starter point on the matrices. Now matrices, it's not something that is very complicated. Is actually defined as a row by column expression. We actually define them as matrices. A row by column expressions, we define them as matrices. So one can ask to say, what is a row, what is a column statement? For example, we can actually have a matrix A as a row, so it means that I can have A, B, C, D. So this one is called a matrix and it's called a 2 by 2. I can have another one as A1 is equal to maybe AB. So this one is the column matrix. So in this case, I've got a row, I've got 2 rows, and I've got columns, I've got 1 column. So this is called a 2 by 1 column, whereby this other one is called row 2 and the versus column 2. So it's called a 2 by 2 matrix, whereby I can have another one A2 as a AB, like this one. So this one is row 1 and multiplied by column 2. So it is called a row by 2 column. So it's row 1 and column 2. Now, so this is the way we can actually represent matrices. And then if I have got like A and A as A, and this one I've got A, B, C, D, then this one value is called a scalar because it can multiply each and every value in that particular statement. So it's called a scalar. A scalar is a constant. So we can be able to say 4, 1, 3, 2, 1. So this means I can multiply each number by 4. So it will be 4, 12, 8, and 4. So this is actually the sum that we can have. And so 4 is actually a scalar which has multiplied to give us this particular matrix. So let's look at some rules pertaining to matrix. So the first rule is called additional rule. So under additional rule, we can actually have matrix A, B, C, D, and this particular matrix can actually have K, L, M, N, like this. So in terms of additional rule, you can actually say A plus K, and then B plus L, and then C plus M, and then D plus N, so that at the end of the day, you are able to find the sum. For example, I can have matrix 1, 2, 3, 4, and then I can be able to add this one 2, 2, 2, 2. Then in this case, if I can be able to add, I can have 1 plus 2, 2 plus 2, 3 plus 2, and then 4 plus 2. So that in the process, you have got 3, 4, 5, and 6. So this is actually the sum matrix on that particular part. So this can be applicable even when we are subtracting. So when we are subtracting, it means that the scenario can be the same. So that's the point. And the other point which we can be able to look at when it comes to matrices is other calculation. Now let's look at the other rule, which is the multiplication rule. Under the multiplication rule, you can actually have a matrix AB, CD, and another matrix you can actually have KL and MN. So normally when you are multiplying in any matrix, this is row 1 column 1, and this is row 1 column 2, and this is row 1 column 3, and this is row 2 column 1, and this is row 2 column 2, and this is row 2 column 3. So it can be like that. So it means that this space is R1C1, R1C2, R1C3, R2C1, R2C2, R2C3. So I want you to understand it in that particular process. So when you are multiplying a matrix, normally what you do is you take this particular row, you take the row, and multiply by a column in the other part. So you take this row, multiply by this particular column. So in this case, I can say A multiplied by K plus B multiplied by M, and then I will take row 1 still and column 2. So I will put an answer here. So I will say A multiplied by L plus B multiplied by M. So that now if I'm coming here, it means that I need to take row 2 and column 1. Row 2 in this matrix and column 1 in that particular in this second matrix. So it will be C multiplied by K plus D multiplied by M. Now if I come at this last point, it means that I need to take row 2 and column 2. So this is row 2 and this is column 2. So I will say C multiplied by L plus D multiplied by N. So that at the end of the day, you are able to determine the values that can be established from that particular point. So in a practical scenario, we can substitute these ones by putting numbers. And if we put numbers, you can easily just substitute the values. So it can be numbers like 2, 3, 4, and 1. And then on the other part, it could be maybe 4, 3, 4, 1. So if you can substitute the numbers, you can easily get the values at that point. So just to give you like this and that only, in the interest of time, we can actually say for those matrices, you can get you can actually get 2 multiplied by 4 plus 3 multiplied by 4. And then for this other one, then it could be given us because that one is row 2 and the column 2. So it will be able to say 4 multiplied by 3 plus 1 multiplied by 1. And then this one, it means that it is row for this one, it is row 2, which is this one, multiplied by column 1, which is that one. So in that case, it should be able to say 4 multiplied by 4 plus 1 multiplied by 4. And then lastly, this one, I'm taking row 1 okay, the row 1 multiplied by column 2. So it will be 2 multiplied by 3 plus 3 multiplied by 1. So that at the end of the day, you can actually now have the sum to say this one is 8 plus 12 is 20, and this one is 6 by 3, which is equal to 9, and then this one is 16 plus 4, which is equal to 20. This is 12 plus 1, which is equal to 13. So this becomes the sum of the matrices. So I want you to take note of that. Now, on the other point, let's look at another situation where we have got now some rules pertaining to the matrices, because each and every matrices, it has some rules attached to it. Some of the rules can be quite challenging to people, but others cannot be challenging to people. But because we are doing the calculations, we can be able to look at the following. Let's look at some rules. We have got what is called associative rule. So we can have matrix A multiplied by matrix B and C is the same as matrix A multiplied by B and C. And the other one is called left distributive rule, which normally looks at this is equal to A times B plus A times C. So it is called a distributive rule, but it's a left, whereby on the right you can actually have it like this, and then C is equal to AC times BC. So this is called right distributive rule. Now take note that in matrices, A times B is not always B equal to B times B times A. This is not the same in matrix mathematics. Why? Is because we have got different results that can define things at that particular moment. So I want you to actually from that particular part, you should be able to do some calculations. Like I can give you an exercise which you can write like to determine and prove this. So we can have 0, 1, and then I can have B is equal to 0, negative 1, 3 and 2, and then I can have C as equal to 1, 1, 2, 1. So I want you to prove these equations and ensure that they are the same. So it means that when you are multiplying here, you are going to multiply, okay, and then here you are going to first of all add, and then multiply with that, and then so that you can prove that you can actually check that it is true, that whatever you can get on the right is the same as whatever you can get on the left, and then try to check if this is applicable again, whether A and B is equal to B and C given these particular equations given. Okay, so we'll continue in the next section by looking at some complexities regarding these matrices in question. I thank you. We'll continue in the next session.